Well, there's that cheesy, actually, it is catchy theme song, which can only mean one thing. It's time for another Ball Publishing webinar. And the topic today, you're looking right at him, beneficial nematodes. Where are we? I'm Chris Beatty's editor of GrowerTalks and Green Profit magazines and the e-newsletter Acres Online, and I'm going to be your host for the next hour or so as we discuss this really fascinating topic. Now, this is going to be a multi-part presentation focusing on where beneficial nematodes come from, how they're produced, how to get the most of them out of them, and the latest research in how to use them. And now, as we have established long ago, I'm never the expert on these topics, but thankfully I know who the experts are. And for today's topic, I've got not one, but I've got two of them. And the first, I think a lot of you, especially if you're already in the biological control business, you know this woman, Suzanne Buglady Wainwright from Buglady Consulting. Suzanne, are you on the line?
I am here, Chris. How are you doing?
Hey, I'm doing great. Now, where are you broadcasting from today, Suzanne?
Well, I could say Eastern Pennsylvania or my sofa, whichever you would prefer.
Well, that's the beautiful thing about webinars. You can do them from any place you've got an internet connection. I won't ask if which pajamas you happen to be wearing today. Now, here's a little-known fact. I like to do these kinds of things. A little-known fact about Suzanne Buglady Wainwright. You are a practitioner of the ancient art of clear candy making. Is that correct?
Yes, it's actually called clear toy candy making, and sometimes people call it barley candy, but it's a kind of candy that was made in the 1800s, early 1900s in the eastern coast of the United States, and I do historic reenacting where I go to sites and demonstrate and teach people how to make it. That's
cool. Have you ever made a nematode shaped?
Not yet, but I do have a grasshopper mold from the 1800s.
Oh, that's cool. So this is really ancient stuff. That's fascinating. I love that. And as I said, we've got two experts. Our second is Julie Graesch from BASF Corporation, our sponsor. And Julie is part of the Seed Applied Agricultural Solutions Department there at BASF. And she's also a member of the BASF Bio team. Welcome, Julie.
Hello.
And you are broadcasting from where? Iowa, I think, right?
Ames, Iowa. Yes, I am. Although I'm in my office, so I'm not in my jammies.
Yes, you have to get dressed up because you're part of the BASF thing. Now, tell us a little known secret about you. We know that Suzanne makes this cool old style candy. What do you do that we wouldn't otherwise know about you?
The last couple of years, I really have gotten into sewing, and so I've made some costumes for my kids. They were dragons this year, and I've also made some quilts and clothing and wall hangings. And so when I'm not at work or playing with my kids, I'm on my sewing machine.
That's cool. So next Halloween, giant nematodes is what I'm thinking for the kids. All right, so
well, they're 10 and 6, so they have definite opinions on what they are for Halloween.
Oh,
I don't know if I can convince them. Maybe not.
And there are no nematodes in my office, and I am dressed today, broadcasting from the high atop the GrowerTalks tower. That's where I'm doing my thing. Now, a little bit of housekeeping before we get right into the nuts and bolts of nematodes. First off, let me say that if anybody's having technical difficulties, you can hit the red Test Your Connection button down at the bottom of your screen, and there's a kind of a self-diagnosis page there. And if you still have problems, we've got a live chat technician on board. Her name is Nina, as a matter of fact, and she can help you out. But I think everybody's probably doing fine. If you have questions as we go along with the webinar, use the question bar that you see on your screen and just type it in. I will be fielding those, and I'll get to them either as we go along, if it's timely to the topic that Julie or Suzanne happen to be talking on, and if not, we'll save it for the end. We've got a Q&A period there. If you either have to leave the webinar early or you want to relive it, you can do that at GrowerTalks.com/webinars, probably within an hour or two of when this concludes at 1 o'clock Central. I'll get it up as quick as I can. And it's the same place you signed up for this webinar, so that's very convenient. And last but hardly least, I definitely want to thank our sponsor today, BASF, who puts the free in free webinar. And I think that is all of our housekeeping. So, Julie, you're going to start us today, correct? Take it away.
That is correct. Thank you, Chris. And I also want to thank Suzanne for being with me on this webinar today. I also want to thank all of you for listening in. It is a pleasure to speak with you today. As Chris mentioned, we're going to be talking about beneficial nematodes and where we're at. Let's see. Okay. So we're going to start by talking about beneficial nematodes and what they are. We're going to talk about a little bit about commercially available species, biology, and target pests that they target. I'm going to talk a little bit about how those nematodes are produced, specifically in vivo and in vitro. They're so close in the way they sound and look. I always color code them, but I color coded them blue and purple just so it's easier to see. Then I'm going to talk about formulation and quality before I pass the ball to Suzanne, who's going to be talking about how to get the most out of nematode applications and what's new in research. Beneficial nematodes, insect parasitic nematodes, animopathogenic nematodes, they all mean the same thing. They are soft-bodied, unsegmented roundworms. They're naturally found in the soil worldwide, and they move through the soil profile in response to host cues, such as vibrations as the insects are moving around, carbon dioxide as the insects are respiring, and other chemical cues, such as volatile organic compounds given off by plants as they are fed upon by insects. It's one of the major things that nematodes can cue in on. Let's talk a little bit about the nematode life cycle. Insect parasitic nematode, it means that it's a parasite. And so they require a host, an insect host, in order to survive and complete its life cycle. So in the picture, you can see everything that's inside the dotted line is occurring inside of an insect. So that is the other juvenile stages, the adult, the eggs. There is one very unique part of the insect parasitic nematode life cycle, which is called the infective juvenile. Also a dower juvenile, the DJ that you can see in the picture. That is a very, very specific stage that's found outside of the insect host, which means it's free living. It's the only stage. It is not growing. It's not reproducing, and it's not feeding or defecating. And so its only job is to find a host, and if it doesn't find a host, it dies. And so once the insect parasitic nematode, the infective juvenile, finds a host and gets inside the host, it releases a bacteria that it carries inside of itself. Inside the insect's blood, it causes septicemia or blood poisoning of the insect. The insect dies. The nematode goes through several generations. And once the insect is consumed, new infected juveniles are produced. They leave the host and go in search of more hosts in the environment. There's around 25 species of Steinernema and around 10 species of Heterorhabditis that have been studied and are used as biological control agents. A little bit more on biology. There is a couple of different ways that nematodes find hosts. The first one is ambush, which is a sit-and-wait strategy, and it is specific to the more mobile insects on the soil surface. So in the picture you can see there is a single nematode that's standing on its tail, and this is called nictation. And the nematode releases itself from the surface tension of the soil and sort of can wave around and kind of taste the air and senses when the insect is getting close, it's moving around. And if it senses that it might not be close enough, it can actually roll itself up into a kind of a curlicue and throw itself at its host in order to increase its chances of coming into contact with those mobile insects. Super, super cool. Some examples of an ambush nematode is Steinernema carpocapsae and Steinernema scapteriski. Steinernema carpocapsae is probably one of those nematodes that is the most highly studied. It is a generalist, so it has the largest host range. Steinernema scapteriski is more of a specialist, and it is specific to crickets, such as mole crickets. Here we're targeting greenhouse, nursery, turf grass, and orchard, such as the shore fly weevils and cutworm pests. Secondly, another strategy in which the nematodes use in order to find insect hosts is cruiser. It's actively searching, and it's going after the sedentary insects that are deeper down in the soil profile. Examples of these nematodes would be Steinernema crossii and glasseri, Heterorhabditis bacteriophora, and megadis. Here we're targeting turf grass and nursery pests such as white grubs and black vine weevils. Finally, there is an intermediate foraging strategy, and nematodes, so obviously that would mean that they're both ambush and cruiser, and those would be our Steinernema feltii and Steinernema rio brave nematodes. And here we're targeting greenhouse, nursery, and orchard pests such as fungus gnats, western flower thrips, weevils, and borers. Now we're going to get into how the nematodes are produced. There's two ways that beneficial nematodes can be produced. The first one is in vivo, which means literally in the living. And obviously those are conditions present in nature. And specific to nematode production, it's production inside of an insect host. Alternatively, there is in vitro, and that literally means in glass or an artificial environment. Specifically for nematodes, it's nematodes being produced in a pure culture of their bacterial symbiont in a nutrient medium in some sort of vessel. There are two types of ways that our nematodes can be produced in vitro, and that's solid and liquid. In the interest of time, we're really only going to be talking about liquid, but know that there is a solid version, typically done on some type of foam or in bags, and it's somewhere in between in vivo and in vitro. It can't produce as much as the liquid form and can produce more than in vivo. The desirable traits that you want off of either one of these production methods, in vivo and in vitro, is high virulence. And virulence means that the ability to search, recognize, penetrate, and kill insect hosts. Also, you want ease of culture, stability, and versatility of the nematodes. So versatility like a carpocapsae nematode that goes after a lot of different insect hosts. Let's talk about in vivo first. There's basically 5 different things that needs to go on to produce nematodes in vivo. The first step is inoculation. So you want to infect the host with the nematodes. Once the nematodes are infected, they're transferred to trays and shelves and put into controlled incubation where temperature, aeration, high humidity, and other things are very closely monitored. Once the nematode goes through its life cycle and the infected juveniles are produced, they're harvested, and depending on the producer of beneficial nematodes, this can be done by a white trap, mist chamber, or drip irrigation. Once they are harvested, they have to be concentrated, and typically any of the harvesting methods are dealing with water, so they have to be removed from the water, and that can be done by, depending on the nematode producer, gravity settling, vacuum filtration, or centrifuge. And because we're working with nature on several degrees, oftentimes there needs to be some decontamination procedures. Over on the right, you can see a drawing of one type of nematode production for in vivo. This is a very automated system, and so there can be many, many degrees of in vivo production depending on the producer. Yield can be affected by the nematode species itself, and this is inversely proportional to size. So if you look at the picture below, you can see 3 different nematode species. The first one there is Steinonema feltii, the middle one is Heterorhabditis bacteriophora, and the last one is Steinonema carpocapsae. Steinonema carpocapsae is the smallest of these 3 nematodes, and so it would produce more nematodes than the other 2 just because of its size. So that's what it means that it's inversely proportional to size. And this is true to both in vivo and in vitro nematode production. Secondly, in vivo yield can be affected by the host species, and once again, we are proportional to the insect host size. So the larger the host, the higher the yield. And age can also have age of the insect can also have a large effect on yield. The 2 most commonly used species to produce beneficial nematodes in vivo is the greater wax moth, Galeria melanella, and the mealworm, Tenebrio molotter. There's a lot of other ones that you can use, but these are used because they're highly susceptible to beneficial nematode infection. They're widely available. They're used by birders. A lot of people like to feed birds with these insects. Also, fishermen like to use them to feed fish. And they're easy to rear, and they produce high yields both on the insect side and also on the nematode side. Some advantages and disadvantages of in vivo. First, starting it up, there's a fairly low capital outlay and technical expertise. It's not that difficult to get started. Another advantage is supplying small businesses and niche markets. When we talk about in vitro, you were producing a lot of nematodes, and that typically means that volume translates down to the package size, and so you can have large package sizes. And that's not really all that beneficial when you have homeowners or small businesses that need small pack sizes. So this is a wonderful way to supply small pack sizes. There's no doubt that nematodes produced in vivo are of extremely high quality. Culture time is much shorter than in vitro, and it's very easy to adopt new nematode species as long as you can produce reliably a host for that nematode. It's much more difficult to start a new nematode in vitro. Some disadvantages is the cost of labor. There's a lot of steps that go along with producing in vivo. Also the cost of insects, and it costs less to the nematode producer if they can rear the nematode or the insects themselves. Contamination. This is biology, and many layers of biology, and so contamination is always an issue. Economy of scale, just like we can supply small businesses, it's more difficult to supply large businesses. And finally, strain deterioration. And I'm not going to talk much about that now because I have a slide all on strain deterioration. We're going to switch gears and talk about in vitro. So here you have your strain or your nematode and your monoxenic culture, which is the bacteria. And then you have a scale up all the way from flask to large fermentation vessel. Depending on the producer, there could be any number of those. Along the entire way, you can have quality control to ensure high-quality nematodes, both looking at the nematode and the bacteria. Once infective juveniles are produced in the last vessel, they're pumped over into a centrifuge where everything but the infective juvenile is removed. Those are cleaned, formulated, stored, and marketed. A few other things on in vitro. The stock cultures, both nematode and bacteria, are cryopreserved to preserve genetic integrity. The liquid components that go into the fermentation vessels try to mirror as close as possible to an insect host. So that is, and every single nematode species is going to have its own proprietary formulation, and every nematode producer of in vitro nematodes has their own proprietary formulation. But basically you have, yeast extract, grain flour, egg yolk, peptone, milk powder, liver extract, oils, cholesterol, salts. So those are just a few examples of what can be found in the liquid media. Culture time depends on media, the nematode species, and how many scale-ups there are. Finally, yield is affected by genus, so Heterorhabditis versus Steinernema. Steinernema is a much easier nematode typically to rear in vitro than Heterorhabditis. Species, as we talked earlier with in vivo, the larger the nematode, the smaller the yield. Media, nematode inoculum, which means just the ratio of nematodes to bacteria, and infective juvenile recovery, meaning recovering from its infective juvenile into its other life stages, all affect the yield. Advantages and disadvantages. The cost of labor is less than in vivo because you can have much larger volume based on the number of people that can produce that volume. Economy of scale. Large volumes can be produced, and so it's definitely an advantage. Like in vivo, extremely high quality nematodes can be produced in vitro. You also have less space requirements and waste in relation to in vivo with the number of nematodes that are produced. And finally, it's easy to harvest. It just goes from a fermentation vessel to centrifuge. Disadvantages, much greater capital investment. I mean, we're talking about highly technical fermentation equipment, and so you have to have also a lot of expertise to run that fermentation equipment. In addition to the technical expertise to run the equipment, you also have to have people with a lot of knowledge on the nematode's biology and behavior, as well as the bacteria that the nematodes carry. Culture time is typically a lot longer than the in vivo. Contamination, like in vivo, contamination can also be an issue, and of course there's a lot of quality control that goes on there. And finally, strain deterioration. Well, there's that word again, so let's talk about strain deterioration. It happens via repeated culturing, and it's a concern for both in vivo and in vitro production of nematodes. What happens is there's a reduction in beneficial traits such as virulence, environmental tolerance, and reproductive capacity. However, the producers of in vivo and vitro nematodes can mitigate these and be prevented by precisely controlling production conditions such as temperature, humidity, aeration, osmolarity, and so on. Minimizing serial passages, and that way you don't have the inbreeding concerns of the nematodes, and so on. Introducing fresh genetic material, cryopreservation of stock cultures, both nematode and bacteria, and use of homozygous inbred lines resistant to trait deterioration. There's a few misconceptions out there in the marketplace. The first one is in vivo nematodes are better than in vitro, and I hope with the last few slides I've instilled in you that high quality nematodes can be produced by both production methods. Secondly, more infective juveniles in vivo formulations than in vitro formulations. Well, if you remember back to my discussion about the life cycle of the beneficial nematode, the only stage that's found outside of the insect is the infective juvenile. No other life stage can survive outside of a host. They die. And so if you get a package of beneficial nematodes, whatever's living are infective juveniles, and there's no other. That's the only stage that can survive outside of the insect. And finally, you can use lower rates when using in vivo nematodes. Generally speaking, 1 billion nematodes per acre, or 25 nematodes per centimeter squared, is needed for soil insect efficacy. Now, that is a generalization, because every single nematode, when it's paired with its insect host, it has its own set of rates and rate ranges. However, and a lot goes into that. You can use lower rates, and they can be effective, especially if you're targeting particularly susceptible insects. You might need to use more nematodes if you're going after insects that are deeper down in a soil column. You may require less nematodes if you're applying them in very controlled environmental conditions, such as greenhouses and nurseries. And I encourage everybody to ask the producers of nematodes for data on rates, because they should have that. My last couple of slides on nematode production are on 3 different host species, but basically here they looked at the different ways of producing the nematodes. So the first one here is the Diaprepes root weevil. And it was paired with the Steinernema rio brave, and here we have control, which is no nematodes. G is in vitro granular, L is in vitro liquid, and V is in vivo. And on the percent mortality here, you can see equivalent larval reductions based on the nematode production method. Next is the Japanese beetle, and once again we're looking at population reduction here. And this particular researcher looked at 2 different nematode species, Heterorhabditis bacteriophora and Steinernema carpocapsae. And let's start by looking at carpocapsae, which is in the white. And once again you can see in vivo, in vitro solid, and in vitro liquid. Once again, we have equivalent larval reductions based on the nematode production method. Now, if we look at Heterorhabditis bacteriophora, we only had equivalent larval reductions with in vivo and in vitro solid, and there was significantly less population reduction with liquid. Finally, we have a study with black vine weevil. Once again, we're looking at host mortality, and here we're comparing in vivo, in vitro solid, and in vitro liquid against a chemical standard. And once again, Steinernema carpocapsae has provided equivalent larval reductions. That is the end of my discussion on nematode production, and so we're going to then move into formulation and quality, which are important aspects of commercialization. With the formulation, it requires an effective formulation provides shelf life, stability from transport to application, ease of handling, and field efficacy. Formulated nematodes, require oxygen, because these are live organisms. Obviously, they need oxygen. They also need moisture. And thirdly, they need immobilization. And you can do that via cold temperatures and partial desiccation. And here's my BASF plug. So when BASF is a producer of in vitro nematodes, it's done in Europe, in the UK, and once the nematodes are once the infected juveniles are harvested and formulated, they are put into cold storage. Once they're shipped to the United States or wherever, they are put in refrigerated boxes that are kept refrigerated until they get to a storage facility. They are taken out of the refrigerated boxes and immediately put into cold storage again. When the grower purchases beneficial nematodes from BASF, they are directly shipped from BASF to the grower. And when they are direct shipped, they are put into packaging that is like a cooler, and there is cold packs inside those in order to prevent the nematodes from getting warmed up. In the picture, you can see it's important to keep the nematodes from warming up because, as you can see, some nematodes in this formulation crawled out of the formulation when they were allowed to warm up. So anything outside of that package crawled out of its own volition. And obviously that's bad because they're going to desiccate now, and there's also contamination issues. But if you remember again from the nematodes biology, the infective juveniles are non-feeding, and so that means that they only have a certain amount of energy or lipids. And once that's used up, they die. And so it's important to keep them cold because once you get them out to their final destination in the greenhouse or in a nursery, wherever they're going, if they don't have the lipids to get to a host, they're not going to infect. So it's very important. Formulation, they can be found in a variety of formulations, and every nematode producer has their own proprietary formulations. But a few examples here are activated charcoal, baits, clays, polyurethane sponge, vermiculite, alginate, and polyacrylamide gel, insect cadavers, liquid concentrate, wettable powder, water dispersible granules. So those are all examples of ways that nematodes can be formulated. Quality, the main thing is that you want to ensure that you're getting your package claim. So if it says 50 million nematodes on that package, you'll want 50 million or more. And we always encourage growers to check the nematodes by looking at them underneath a hand lens or a microscope. And obviously you want to see nice squiggly nematodes, and you do not want to see the straight ones. Sometimes nematodes can be shocked when putting them in water, and so you want to make sure that you leave them in water for a little bit before you look at them, just to ensure that they are waking up and moving around. Some other things that you would associate nematodes and quality is virulence, so its ability to kill, size and sturdiness of packaging, clarity and accuracy of instructions, dispersibility, so you want to put it into water and you want it to disperse into there and then be applied evenly, storability, ease of transport and application, and finally, and obviously, the absence of contamination. My take-home messages before I pass the ball to Suzanne is that in order to meet market demand, both in vivo and in vitro nematode production methods are needed. There is equal concern for strain deterioration for both rearing methods. However, nematode producers mitigate these concerns, and so it should not be a concern of the growers. Finally, consumers' choice should be based on cost, volume, customer support, shipping time, and other factors. If you have any questions, I included my references for your additional information if you would like. And now I'm going to pass the ball to Suzanne. Suzanne, take it away.
All right, thanks, Julie.
Hang on, Suzanne.
Oh,
Suzanne,
did you say hang on?
Before we segue, we had a couple of questions applying to production, so let's grab those real quick.
Okay.
Sarah wanted to know, backing up a few slides, Julie, don't actually physically do it because it'll take a little while. When you were showing the testing of the different types of nematodes and the similarities and differences, she wanted to know if that was real-world testing or if that was laboratory, like Petri dish testing.
I'm not entirely sure if I understand the.
That was when you were
question.
showing the differences in vivo and in vitro, or the liquid and solid. How sometimes there's no difference, but other times there's a big difference in the mortality rates based on the formulation. And she wants to know if those results were generated in a lab setting or in a real world setting.
Laboratory, yes, laboratory.
Okay. And I was curious, since I assume that the typical user of nematodes is not going to produce them on their own. Am I correct? I mean, this looks pretty complicated.
The in vivo,
Go ahead.
Go, Julie.
There are actually procedures out there for making beneficial nematodes via in vivo, and so growers actually can make their own in vivo nematodes. However, it is a lot of work. If you have a savvy grower that wants to do that, then they're more than welcome to, and when we have resources in which that we can get to the growers if they wish to do that.
Okay. So why is it important that a grower understand the production methods for nematodes?
Well, there's a lot of questions out there on how nematodes are produced, and so it was important for me to put the production method in there because there are a lot of questions. Whether you're not new to nematodes or you are new to nematodes, it's good to know, and just to have the conversation, it's important.
Okay. I'm going to make a comment here, Suzanne. Sorry, Chris. Because being out in the field, it's because I hear a lot of marketing strategies saying, well, since we rear them on live insects, our product is better and they perform better. And when you go, again, as Julie brought up some of the research and also from real-world experiences, it's not necessarily always true. You have to look at the pest you're dealing with, the formulation you're dealing with. So you can't say as a blanket statement because it's reared in live host, it is better. And that is something that it was brought up years ago, and now it's coming up again, and I've heard it a lot this year, and I've been asked a lot about that, and that's kind of why I thought it was important to include this so people understand the different methods, and you need to look at your specific pest, again, formulation, everything you're doing to see which formulation is right for what you're doing.
Okay. On that same topic, one of our audience members is asking or saying that suppliers of in vivo produced nematodes will state lower rates, and I assume that's application rates for their products?
Yes.
You've seen it, so why would they state lower application rates for an in vivo versus an in vitro?
Well, and this will be my answer. This is not BASF answer. This is mine. BASF has what I think are higher rates, but it's to ensure that you get effective control. As Julie mentioned in her presentation, when a company comes to you and says use this rate, I would ask them how they came up with that rate. Do they have data to support it? Because there's a lot of wiggle room on rates in the biocontrol world because, we've seen it work at one rate, so we stick with it. We did some trials, seriously, it had been like 15, 17 years ago, and we did find in some situation that the live host reared, we could use lower rates with the live reared nematodes, but the live reared nematodes, they just can't produce enough of them to meet the world's needs. It's so labor intensive, and that is why they've moved forward with the in vitro way of doing it so that they can meet the demands, because, I mean, the demand for nematodes has been going straight up for years because we're finding new things we can do with them all the time. So, you know, if somebody recommends lower rates, ask them how they have those numbers, if they've got data to back it up.
All right, good. And there's about 400 more questions just came in, but we're not going to hit those till the end. So, Suzanne, take it away as getting the most out of your nematodes.
Yeah, now that I have 10 minutes to do mine, okay, we'll get through it as best as we can.
So, take 15.
Okay, 15. All right, thanks, Chris. So here's the list of stuff I'm going to go over, so you don't have to read this list because we're going to hit all these topics, and you can always go back and look at the webinar online afterwards. For me, this is the most important things, and if you guys have been to my workshops and classes, you know, I will beat you over the head about you've got to identify what your pest is. And if you don't know what your problem is, we can't give you good solutions to your problem, so no guessing on identification. Now, once you do know what you have, when it comes to nematodes, and you'll see lots of really massive lists out there. I mean, I've seen some pretty incredible things that people say nematodes can do. This is my greenhouse short list of where I'm feeling pretty comfortable at. I mean, western flower thrips, yeah, we know we've got this with nematodes. Same thing with fungus gnats, pretty good control of shore flies, black vine weevil, cutworms, banana moth, that's a tropical pest that we deal with in tropical areas. The thing I wanted to mention, too, is root aphids, because this has come up over and over again. It's no secret root aphids are a problem in cannabis. I'm seeing them in ornamental vegetables, in vegetables, and I'm also seeing them in ornamentals in grasses. So root aphids are out there in all segments of our industry. The thing I want to point out is there's a difference between can you infect it in a petri dish, and does it work to control the pest out in the real world, which that was a good question somebody asked before, you know, was the research done in real world situations or in a petri dish? Initially, all these tests are done like in labs, and I'm doing air quote petri dish because it doesn't necessarily mean literally a petri dish, but under, you know, very tight parameters where you can control all the different variables in it. Just because a nematode can get inside of a root aphid does not mean that it is going to control it out in real-world growing situations, which is very important to understand. I will say this again, just because Streliolapsus feeds on a black vine weevil in a petri dish does not mean it's going to control it out in a growing environment. And that's very important to understand when someone is making recommendations. Is the recommendation being made off of, you know, something that was seen or observed once, or does it actually control it? And then I have on here, too, my list of just nope. You know, I get these questions. I get a lot of questions through Instagram these days, and I've been asked if nematodes will control mites, and they do not, because mites are not insects. Poinsettia thrips, which is important. That's the thrips on the lower right-hand side, which we do see in ornamentals, vegetables, and cannabis. Nematodes will not control that because it does not pupate in the soil, and I don't think they've ever done any research on trying to control it on the foliage, but it tends to hang out on the undersides of the leaves, and you're going to have a hard time getting nematodes in contact with it. And again, springtails are another one that is coming up a fair amount. No, those, we have not to this day seen them work to control them because, again, columbella are not insects, and these nematodes really target more insect pests. This is not the be-all, end-all list. There's a lot more, but I tried to keep it just basic and simple for today's purposes, for time mainly. So with identification, and if you guys aren't following what's going up at the Omphra station up in Canada, Dr. Sarah Jendrisic has been doing some great work. And why this is important with nematodes is when people say they have a thrips issue, if you've asked me, I'm always going to ask you, what kind of thrips do you have? And most people assume they have western flower thrips. This was a survey she did 2 years ago up in Canada, up in the Niagara region, and only 65% of the thrips they saw in greenhouses were western flower thrips. 33% were onion, They had 1% echino and 1% other. I'm sure this will change throughout different parts of the country. The reason this is important is to understand not every thrips you see is a western flower thrips, even though when you Google thrips, most of the Google returns you're going to get are going to be for western flower thrips because they've been of such economic importance. But be aware there are lots of thrip species. And Sarah's done a great thing. She has on her blog here, and you guys can go back in once this is over and get this PDF, or you can just Google, Sarah Janrisic for thrips, and you can find it. But she's put together a document designed for growers on thrips ID. Here she's going to give you basic anatomy terms you need to know, and here, this makes it real easy for you comparing the differences between a western flower thrips and an onion thrips, and how you can tell the difference by looking at the hairs, basically on their neck hairs, and also looking at, they've got these little dots between their eyes, and looking at the colors of them. So this key is really designed for growers to use, and then it can help you identify what thrips you have. Once you know what thrips you have, you can look at the biology, and then you can look and see if work has been done using nematodes to manage them, to see if nematodes will work for your thrip species. So I can't push identification enough because ID is so important when you're dealing with biocontrols. So something, too, thinking about using nematodes is looking at the environment. And where do nematodes live? They live in the media. And soil temperatures are something I've been very interested in for years because, as many as you know, I work from Canada all the way, well, I've worked as far south as Grenada, but I do spend a fair amount of time working in the warmer environments of Florida and California and Texas and those areas. And I've always been very concerned about the soil temperatures and if they're too hot for beneficial nematodes. Here on the right are the recommended temperature range from BASF for their nematodes. If you're dealing with any company that sells nematodes, you should ask them for the temperature range for their nematodes. But there's some new research on soil temperatures, which I'm going to go over at the very end. But this is something I wanted you guys to be aware of, that some nematodes don't do well in really hot environments. And in the south, if you start measuring your soil temperatures, you'll be amazed at how warm they can get. And even up to the Carolinas, we've had issues with nematode performance because of heat in the soil. So it's something you guys do need to be aware of. Also, you need to be looking at what soil types, whether you're using actual media like, a peat moss based or a cocoa based compared to like rockwall, because how nematodes perform them can make a difference. And it's been very interesting in certain markets that have been dealing with certain pests, because when you get into rockwool, some of the biocontrol agents do not perform nearly as well as they do in soil, because soil would be their native habitat. And there's actually been a little research done comparing nematodes and peat versus rockwool, and they were actually looking at shore flies for this study, and they looked at Stenofeltiae and Carpocapsae, and they compared them between peat moss and rockwool. If you want to read more about this, the citation is in here where you can go get the paper on it. But the basic message from it was that at first, when they were applying the nematodes at the beginning with the treatments, when they got 2 application rates, they were actually controlling them 83 to 84%, which is good. But when you look at over a 4-week period, they actually only got 46% control in the rockwool. And they think what's happening is the nematodes are actually washing out of the rockwool. And Julie and I have talked about this, because I do think with rockwool it's going to make a difference if you're using overhead irrigation, NFT, or basically a straight up sub-irrigation, and how fast the water is moving through the profile. Because I think if you're doing overhead irrigation and it's forcing the water down, it could force the nematodes faster out of the rockwool than if you were just doing a traditional ebb and flood system where the water comes up from the bottom and wicks up. And I do think with an NFT you could lose some too with the water flowing from the sides. So something to keep in mind, that your application frequency and rates may need to be altered for use in and rockwall compared to traditional medias, and most research is done in traditional medias. So keep that in mind. Also with your nematodes, you need to make sure you select the right species, and BASF, as well as other companies, have a pretty good extensive list of what the nematode species do control. Again, I think there's this fine line between control and suppression, and is it going to eradicate the problem? Is it going to completely knock it back? So when you're buying your nematodes, you need to talk to whom you're buying them from and get a realistic expectation of the level of control you can expect to see with them. And also, if you are looking at research, make sure you look to see how the research was done. You know, there's been some research where they're actually using nematodes to control leaf miner, but that was under a fog house condition, and most of us are not growing in that kind of a situation. So you have to look to see if the research translates to how you are growing, which is very important. The other thing with nematodes, and I know a bunch of you that are on here that I know we have talked about this till I am blue in the face, but I can't say it enough because I was just at a facility not too long ago in Florida, and literally the nematodes were pushed up against an ice cube tray in the refrigerator with a bunch of other stuff. If you're going to store nematodes, you really need to store them in a nematode refrigerator so people aren't opening and closing it all day. If you put a thermometer in there and the door opens and closes all day, you'll see where you get the spikes and drops in temperature. Julie talked about, you know, once they start to warm up, they're using their stored energy, and then they're not going to be able to perform as well when they get out. And typically, again, people put this in the refrigerator where everybody keeps their lunches and drinks and the doors are opened and closed. So, you know, storing them at 40, keeping that door closed, and also keep in mind different formulations have different shelf life. Clay is going to be different than gel, which is going to be different than a sponge packaging. So, again, when you buy your nematodes, ask your supplier, hey, when I get them, how long can I store them before I have to use them? And, of course, they're going to say, well, use them as soon as possible, but we realize sometimes that doesn't always happen. I do have to say, and I'm not this is, I don't want to say it's a plug for BASF, but I think this is a good thing BASF has done, is they've actually offer now free shipping on their nematodes. And this is actually to kind of discourage people from buying a bunch of nematodes and trying to store them, because this way, if you don't store them, BASF knows how to store them better. You can get fresher product, and this way they can just be drop shipped direct, so you don't have to worry about storing them, and that's a good way around the storage issue. Now, as far as application, there are so many ways to apply nematodes. That in itself is a whole presentation. You know, I in my house, I put them in a watering can and water my house plants. All the way up to Florida, we've actually put them out with orchard air blasters and then irrigated to wash them into the soil. Most greenhouse growers are going to be putting them out with either a backpack sprayer, a boom sprayer, using a dosatron. There's a lot of literature available on how to use nematodes with a dosatron. So there's plenty of literature on it. Just, again, get with who you're getting your nematodes from and finding the best application method for your system. As far as water temperatures, I say it all the time, treat them like goldfish. When you bring fish home, you don't dump them right into your tank. You float the bag of water with the fish in the water to bring the temperatures close. Do that with the nematodes. You want to take the nematodes from the fridge and then let them kind of get to room temperature or closer to what your water temperature is. If you have very cold water, you have a better chance with them if they are coming from the fridge. But if you have room temperature water, again, let the nematodes warm up so they're somewhat close for application. Another area that there's a lot more focus on is nematodes and compatibility. Actually, I think BASF has some of the best compatibility information out there, and actually Julie is working on she's doing work in taking nematode species and exposing them to some of the newer pesticides on the market to see if they're compatible or not. It's kind of interesting because some things you wouldn't think they're compatible with, they are, and some things that you think would be safe for the nematodes aren't. So it's very important to check if you're using any other pesticides as drenches, or you want to tank mix your nematodes with pesticides before drenching. You check with BASF or your supplier. You know, BioBest and Culper have very good chemical compatibility apps available that you can look information up in, but I do think BASF has the most current and probably the most wide-reaching information because they are constantly testing products to check for compatibility. So that's very important to look at that. Also on the application, and again for time's sake, you guys can read this after the fact, but the main way I see people killing nematodes is they cook them because they leave their tanks out in the sun. They apply them in the heat of the day, and again, that's not a good application time for nematodes. Early morning is the best. I don't think you guys have to worry about exceeding 300 psi for what you're doing in a greenhouse. But agitation is something that's very important because nematodes do settle out. And this is something that can be addressed in a few different ways. On the left is this dram nematode bucket. I love this because it's just simple and easy. You put your nematodes in there with your water, you flip the switch, and it aerates and it circulates the water, so it keeps oxygen for the nematodes while they're in there, and then also keeps them from settling out. It can be battery powered or plugged in, and this with a dram injector make nematode applications super easy. On the right, we have kind of like the homemade MacGyver version where you get a fish bubbler, which it does oxygenate the water, but you've got to watch because your nematodes will settle in that because you can't get as much agitation with that to keep them evenly distributed through the water. But if you're going to get them out quickly, that kind of method works fine. Once they're out, you want to check and make sure they're alive. One of the easiest things to do is if you save the trays the nematodes come in, rinse them out, and then go set them out where you're applying your nematodes so you catch the water with the nematodes in it. You can just use a 10x hand lens and then hold a flashlight from underneath, and you can see into the water, and then you can see if the nematodes are swimming in there or not. And that's a very easy, quick way to check, because what often people do is they check the nematodes to make sure they're alive when they come out of the package, but they don't check to make sure they're alive when they're coming out of the end of the hose, and that's the most important place to check to make sure they're still alive, because that's where a lot of them are killed. And again, it's the hoses laying out in the sun or the tanks being in the sun and them heating up. Another way that we've been testing, which is a bit more advanced, is Julie talked about Galeria, which is one of the insects they use to rear nematodes. You can just go buy nematodes at the you can go buy the Galeria at a pet shop, and it's what I've done. And then you can actually just cage these Galeria on the soil surface. And then within a few days, you'll know if your nematodes that you've applied into your soil are effective or not. And depending on which species you've used, if you've used a Steinerma species, they turn this color where they're kind of a more beige instead of a creamy white. And if you're using a heterabditid species, they actually turn more of this reddish color. And I've done this with some of my growers, and we've been actually able to check to see if the nematodes that are out in the soil are actually infective, so we know they're working. You can take them and put them under a microscope and stab them, and then you can see all the little nematodes that were reproducing in there. One last thing I want to touch on is there's some new research, and I have begged and begged for this research, and thank you, Cornell. I cannot thank you enough for doing this research, and thank you, Anna. She's awesome. She's doing this soil temperature research up in John Sanderson's lab at Cornell. And so if you ever see Anna anywhere, make sure you give her a hug and thank her for doing this work because it's so important. But basically what she's doing is she's taking the common commercially available species of beneficial nematodes and looking at them exposed to different temperatures for different periods of time to see if they can survive and can they still kill their host. Because heat is a big problem, as I mentioned. If you're growing hanging baskets up in the roof of your greenhouse, it can get hot. And again, down in the south with tropical foliage, these temperatures in the soils can get extremely high. So what we have now are just some very, very preliminary results she shared with me. So there's going to be a lot more she exposed the nematodes to. And so far, and again, this is very preliminary, what we know is that, and this is just talking about did they survive these temperatures for the different time periods, not the part where she puts them back in and see if they can actually kill insects. But we know at 86 degrees, all nematodes survive. So if your soils are at 86 degrees or a little bit lower than that, you're good. Once you get up into 95, the Sternema carpocapsae actually had better survivability with, unfortunately, Sternema feltiae, which one is the one we use the most, did not fare so well. And when you took these species and exposed them to 6, 8, and 10 hours of exposure, she was getting up to 95% of mortality. So it looks like once we get up into the 95 range, we really start having some issues. And once you got to 113, carpocapsae is the only one that had any survival, and that was only for 1 hour exposure. Anything past an hour, carpocapsae couldn't handle. So from this preliminary research, it's looking like what we might need to do, and this is not the be-all, end-all yet, but this is the direction the research is looking, that during the heat of summers, we may need to switch to carpocapsae more for control than feltiae, because it doesn't look like feltiae is going to hold up under these higher temperatures. But once we get the data on are they able to kill, because maybe carpocapsae can survive this 113 degrees for an hour, but then maybe it can't infect and kill pests. We don't know yet. So that's the stuff we're waiting to find out. So more to come on that in this new year. So I want to thank everybody for coming today. I know we went a little over on time, but hopefully Chris will give us a little more time to answer questions. And yes, Julie and I are good friends outside of the bug world. Julie and I went to Scotland together, and it was awesome. So thanks, Chris.
Did you have your hand lenses with you, though? I bet you did.
Of course, Chris. I mean, come
on. All right. Well, let's dive into some of these questions. We can't quite tackle all of them. Some are a little bit complicated. But, Suzanne, any beneficial nematodes useful for rice root aphids? Brian wants to know that one.
No, Mr. or Mrs. Cannabis person. Like I said, at this point, a nematode can get in there, but if nematodes work, there would not be a biblical plague of rice root aphid in cannabis. It's in wheat. It's now we know in peppers. It's in ornamental grasses. So it's everywhere in greenhouses. So I, at this point, don't feel comfortable recommending nematodes for control of rice root aphid.
All right, somebody's got to breed one. James wants to know, you talked at the end there, the new research in soil temperature. What about ideal soil moisture level for nematodes?
I don't know. Julie may be able to answer the percentage, but too much water is not good, because nematodes are considered semi-aquatic, and they basically slide on the water. Because if you put nematodes and put them in straight water and leave them, they do die. So typically, I will say if you're growing plants in it, you're going to be okay, as long as they're not aquatic plants. But what we see in the greenhouse is usually fine. Mist houses are fine. They perform very well in propagation systems.
Yeah, I'd assume you'd want to take care of the plants first, not the nematodes, as far as soil moisture goes. Along the same lines, can you use nematodes successfully in a hydroponic system?
Well, it depends. Again, that's a broad-ranging question. Is it sub-irrigation? Is it an NFT? You have to look at that situation. Are you using soil in net pots? Are you using soil in fertile pots? Are you using rockwall plugs? Are you using glue plugs? I have to know all that stuff before we can have that discussion.
All right, Anthony, send her an email. We'll give you that at the end. Well, you can see it right up in the slide right now there. Let's see. Here's maybe one for you, Julie. Will there ever be a combo pack of, and excuse, I can't pronounce these things, Carpocapsae and Steinernema?
And you mean like a Carpocapsae and a Feltii?
I guess so.
So right now, BASF doesn't have a combo pack. You can always buy both of those from BASF, and you can combine them in a tank if you were trying to control multiple insects that both of those nematodes need to be. So yes, you can combine them. We don't currently have one that's combined. However, I do believe, and Suzanne, chime in here, but I do believe some of the other companies may provide combo packs.
They do, but Julie and I many years ago had a discussion about this because depending on the nematode species, they have different ideal storage temperatures sometimes, and I think you said to me, Julie, that the people that combine them, sometimes it's possible that one nematode species may suffer a bit if they're not stored right.
That can be, especially with like Steinernema rio brave is a warm-loving nematode, and so it needs to be stored at a higher temperature than the other Steinernemas, and so that can be an issue. Rio brave isn't as common of a nematode used, but I guess the answer to the question is you can combine them either separately or from companies that provide them in combo packs, which I do believe there might be some of that out there.
There is.
All right. We've got a couple of good questions from Tina. Well, first off, she wants to know, are they effective in real soil? And we've talked a lot about, potting mixes of, artificial medias, things like that. What about good old-fashioned dirt? I would assume, yes, absolutely. That's where they came from originally.
Absolutely.
Well, it depends.
And,
it depends.
Go ahead, Julie. Well, when you have heavy clay
It
soils.
does depend.
One at a time, ladies.
Suzanne.
Okay. So I'm just going to say it depends on where you are. I mean, we use them in turf. We've used them outside. But if you have heavy clay soils, it's harder for them to get through them. If they're being used quite extensively in upstate New York for alfalfa weevil control, that's a program Cornell's been working with the farmers up there, and that's where they're actually providing information for them to rear their own nematodes because there's a particular strain they're working with. And that is ideally where it works well, and they're doing it out on farm fields. But again, if it's a heavy clay soil, they're not going to do as well. Okay, go, Julie.
I was just going to say that absolutely they do work out in the real world in like turf. Typically, if you're going to be applying, there are of course caveats. They're going to work better if on turf, especially like on golf courses. They're watered, and they can somewhat take care of the nematodes. They're homeowners' yards. But if the homeowner, say, applies them to their soil, they do need to take care of them after they've been applied. For instance, you can't just apply them and then not wash them in, because if you leave them on the grass, they're going to die. They're going to desiccate. So you have to apply them, then you have to wash them into the soil, and then you typically have to keep that soil moist for 1, if not 2 weeks after application for best application results.
There you go. Now, we've had a couple of questions on application frequency.
That's going to depend on the insect. It's going to depend on the environmental conditions. There's so much that goes into that, like anything. And typically, especially if you're in a greenhouse where you could be washing the nematodes away, or heating up a soil profile and killing some of those nematodes, it's always best to reapply nematodes on a regular basis. Yes, they do reproduce inside the insect, and more nematodes are then released into the environment, but that's not always the case, especially depending on the host and a variety of other factors. Suzanne, do you have anything to add?
Yeah, and
No, I
Kelly is
basically
asking about outdoor production with overhead irrigation in their specific case.
Well, it's hard not knowing the pest. Also, when you get outside too, to hand drench every pot, it's very labor intensive. So that's why some people have looked at using, like spraying them and then washing them in, or using an orchard air blaster to put them on and wash them in, and then you don't get the volume of nematodes into the soil like you would with a drench. So you may have to come back and do it more frequently because of just the numbers you're actually getting in the pots. But if you have ideal conditions and a large enough host like black vine weevil, then they can get in those and reproduce. But this is where, if you're not sure if your nematodes are holding on or not, that's where that Galeria test I talked about. You can take a sample of your soil and you can put a Galeria on the surface, or take some of the soil out, put it in a container, and slap a Galeria in there and see if it becomes infected. And that's why we've been doing this testing, is seeing about persistence of nematodes in the soils under different growing environments, because obviously if there's lots of food and you have ideal moisture, they're going to survive longer than if it's not ideal conditions. And that's why there's so many variables, and there's not a clean, easy answer. But no, in a greenhouse, I don't think you need to be applying nematodes every single week, for fungus gnat control. You don't need to be doing that. But you might have to do repeated applications through the entire crop cycle.
Okay. Chris wants to know a couple of application questions. Chris wants to know if sprayed nematodes would be effective against caterpillars on foliage, like loopers. What species would you recommend?
Okay, so I'm just going to say no, because they're not going to have the right conditions to do it. They're better off, using a BT or something like that. It's going to be too complicated, and the chances of the nematode surviving that long and the nematode getting in contact and getting inside of it on the foliage are pretty slim. Now, there is some research for caterpillar borers inside of trees where they spray the trunks of, they're targeting lesser peach tree borer, but what they actually do is they mix a nematode with a flame retardant. This is amazing research that was done down in Georgia by David Shapiro, but they mix the nematodes with basically a flame retardant, and then they spray the trunks of the tree, and it kind of acts like a moisture barrier, and that moisture then keeps the nematodes alive so they can get into the boreholes to kill caterpillars in the trees. They've done that very successfully, but that is not a foliar-feeding caterpillar.
All right. Can you use a foamer for applications, like a disinfecting foamer?
Are you talking about I like the machine that makes it foamy, like that spray gun that foams it, or are you talking about an actual disinfectant product?
No, I think the actual machine that creates the...
Well, I don't know if they've tested that or not, but I can see the idea would be if you sprayed a plant with the foam, it's kind of acting like the flame retardant is, where it's basically holding it on the leaf surface or stems longer to keep moisture, but I don't think they've ever tested it. Julie, that would be a good test for you.
It would be. I guess my only thought on that, without really knowing much about it, would be, yes, it sounds like an interesting application. My question would be application uniformity, and if it's not a uniform application, you wouldn't get, because the nematodes wouldn't go out of that foam, because as soon as they did, they would desiccate and die. So that would be my concern, is application uniformity.
All right, I'm going to just do a couple more here, and then everybody else will make sure you see the email addresses, and you can email your questions directly to both Julie and Suzanne. Is it bad to use only half of a package of Nemesis and then use the rest the next day?
So the answer that BASF wants me to give is no, that it's best to use the entire package once it's opened. the concern is that you could be introducing contaminants once you open it, and that could affect the nematodes. It is also going to affect potentially moisture, because there is not very much moisture in the package, just enough in order to store it properly. And so once you open it, that moisture content is going to change, and you could start desiccating those nematodes. So the answer really is no. Next day you might be able to get away with it if you put some tape on there and you seal the package up really good, but next day only, and I wouldn't go past that.
Gotcha. Okay. Stephen had several questions here, so I want to get to one of his. What do you recommend for shore flies? Which is the best nematode?
Steinonema carpocapsae.
There you go. And lastly, how do we get free shipping for nematodes from BASF? Asks Dean. Probably buy some nematodes from BASF.
Well,
not to turn
you have to go through a distributor to buy BASF nematodes, but any of their distributors, and I'm just like Southern Ag, or I can't even, that's terrible. I've only, for some reason, only one distributor is coming to the front of my head right now. But any other distributors, when you order from, they should provide you the free shipping from BASF.
So even though you do purchase the nematodes through a distributor, they are still shipped directly from BASF. So the distributor doesn't touch them. It's all shipped direct. For BASF specifically, I don't know what other nematode companies do.
Yeah, just make sure they're not tacking an extra charge on the bottom, your distributor, right, that they shouldn't be doing, at least for that part of the order. I didn't say that. All right, now, sorry for the rest of the questions. But if you have them, Suzanne, is that that's a different address than the one that you were showing on your slide?
Well, the other one's just shorter, but anything at Buglady Consulting comes to me, so.
All right, Buglady at Buglady Consulting and Julie.Graesch at BASF.com. Don't send your questions to me because, well, we've already established I'm not the expert on nematodes. Now, also, for those of you who are asking about the different papers and the URLs and things like that, I know they went by pretty fast. Email either Julie or Suzanne specifically which one you're looking for instance, how to grow your own nematodes, that information. Otherwise, if you want to go back through the webinar and look at those specific slides, I know there were questions about which chemicals may not be so good for nematodes or what pests are they effective against. You can go to the archive. I'll get it up within an hour or two. I'll do it as quickly as I can, I promise. And you can find that at the same place you registered, which is GrowerTalks.com/webinar, so you can go back in and reference the specific slides. And gosh, we do want to thank BASF for sponsoring this webinar, making it possible. Some really good information out there for everybody who's into biological controls. We'll have to do some more of these. And so that said, I want to thank the Bug Lady. Thank you, Suzanne. I want to thank Julie. I want to thank all of their nematode friends, and for all my staff at Ball Publishing who are very beneficial to me. Do you see what I did there? I want to wish everybody a Merry Christmas, a Happy Hanukkah, Happy Holidays, and a Happy New Year. So long, everybody.